Hey, how's it going, guys? So in this video we'll discuss about this problem, minimum path sum. So given a m cross n grid filled with non-negative numbers, find a path from top left to bottom right which minimizes sum of all the numbers along its path. Note, you can only move either down or right at any point in time. So let's look at this example. So in this example the output is 7 because the path 13111 minimizes the sum. That is, we have to reach from this end to this end and we have to find the minimum cost. So this is the path 13111 which constitutes the minimum path. So let us look at some of the insights of this problem. So suppose we are given this grid. Now one insight is from an index I comma j, I can only move to either ij plus 1 or I plus 1j. That is written over here. So what we can do is, in order to find the minimum cost from this point, what we can do is we can find the minimum cost from this point to this point. Then we can find the minimum cost from this point to this point. Then we can take the minimum of these two costs and we will just add the current grid value, which will give the answer to us, which is written over here. So min cost from I comma j is same as min cost from I plus 1j, that is this thing, and min cost of I comma j plus 1, that is from this point, and we can just add the grid value, that is this value, in order to find the min cost from this point. So we will write a recursion to it. So let me just write the code and things will be more clear then. Okay, so what we can do is, let's write this method min cost, which takes the array and the current position I comma j. What we are saying is we will find the min cost for I plus 1 j and I j plus 1, and we will simply add the current grid value to it. That is, in order to find the min cost from this point to this point, we are finding the min cost from this point to this point. We are finding the min cost from this point to this point. Once we have those minimum costs for this point and this point, we will take the minimum of these and we'll just add the grid value to it. Okay, so some of the base cases that we need to handle is, so in case I equal grid dot length minus 1 and j equal grid 0 dot length minus 1, we will simply return the current grid value. Okay, one thing to note over here is, suppose I am at this index, so it will try to call for this index and this index. Now this index is out of this matrix, so we need to return the maximum value possible, so that once we take the minimum of two values, it will only pick this thing. So what we can say over here is, in case I equal grid dot length and j equal grid 0 dot length, we will suggest it's not an and, it's a or, either this or this. Then in that case we'll return integer dot max value. So now we'll call this method from here for grid and starting point 0 comma 0. I guess that's it. Let me just submit this. Okay, let me just submit this problem. Let me just try to run it first. Okay, so it's giving the correct result. Let me submit it. Okay, so this is giving time limit exceeded. Why is that? Okay, let's try to analyze the solution and let's see why it's giving us TLE. So what's happening is, suppose my function name is f. So for f0 comma 0, what I'm doing is I'm either calling, that is f01 or f10. Why I'm saying that? Because for I comma j, what we are doing is we are calling for I plus 1j and I j plus 1. So similarly, you can see we can build this tree. So in this tree you can see that some of the values are repeating, that is this f21 is repeating, f21 is repeating over here as well, f21 is repeating over here as well, and similarly it goes for f12 as well. So what we are doing is we are trying to find the same result again and again and again. So instead of finding this result again and again, what we can do is we can store this result at some point and then we can use that result only. So we won't be calculating it further down, we will just store the result of this. So this is basically a dynamic programming problem. So what we will do is in our code, okay, let us create a DP array. Which will be equals to grid dot length. This will be grid 0 dot length. Okay, let's just fill this DP array with -1. J++. So dp of ij equals -1, and we will pass this dp array in our function. Okay, don't forget to do this dp. So what we are saying is, first we will store this result into our dp array. So what we will write over here is dp of I comma j equals this, and over here we will check before finding, that is before calling the recursion. We are calling the recursion over here and over here. So before calling the recursion we will check if dp of ij is not equals to -1. In that case we will just return this value. What I'm saying is, suppose we hit this f2,1. So as we hit this f2,1, we will store this result into the dp array, and once we hit this again f2,1, what we are going to do is, instead of calling the recursion over it, we will return the value. Okay, so let us submit this. Let us run the code first. It got accepted. Let's submit this result. Okay, so we got a success, and you can see our code is faster than 98.88% of Java online submissions. So I guess this is going to be it. So in case you learned anything from the video, you can hit that like button, and you can even subscribe to my channel for further videos. Thank you all.